I think we should be live in. Yes, I think. बोलना कुछ
आ गया था भाई मुझे तेरा को अभी
in. तेरी आवाज आ रही कि नहीं वो चेक कर रहा हूँ.
हेलो 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 1 2 चेक चेक चेक
I think. बोलना कुछ
भाई आ गया था नहीं आ रही है
आ गया. आ रही है. तेरी
ठीक
आवाज आ
है
रही
अभी
कि थोड़ी
हेलो
सी दी. हाँ बोल.
चेक चेक
मैं
चेक
चेक कर
चेक
रहा हूँ.
हेलो 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 1
आ
2
रही है आ
चेक
रही है.
चेक चेक हाँ ठीक है
All right. Whew. Welcome back. Consistency is maintained. We are back on day 16. Back to OpenUSD certification, learning from the NVIDIA documentation over here. A quick recap. We have started this study module called on OpenUSD. OpenUSD it stands for Open Universal Scene Description. It is a framework created by Pixar to basically simulate or animate multiple 3D artifacts. Um, all of these concepts and these frameworks are going to be used in multiple NVIDIA tech stacks like Omniverse, ISAC Labs, ISAC Sim to create digital twins of any environment for the robots to train into. Um, and based on their training in those digital twins, they're going to upgrade their policy model. And their policy model is in turn going to help them perform the tasks that they are programmed to do. So, what we did for the last 3 days was we went over what OpenUSD is, we went over what setting a stage would look like, and then this was some overview we read through. We read in detail what a stage is. Then we did what a prim is and what's its relationship with a stage, and then what the properties a prim consists of. So we did attributes. Attributes are basically the most common types of properties that we'll work with when creating a scene with a prim. So we went over this yesterday. This was some pretty boilerplate code of how you would basically define a sphere under the world X form, and then some boilerplate code to get the properties and stuff like that. How you will be able to render a sphere and a cube, and then some more examples of how to get attribute values, how to basically maybe set attribute values, or set a color or something like that. You know. So that was pretty much the recap, and today we're gonna start going over relationships in prims. So anything you wanna add?
no I think you have summed up everything as of now I think we did work with friends attributes in our earlier sessions I think and now it's time to focus on the next thing that are gonna be the relationships right so let's get started with what is a relationship right now so a
Mm-hmm.
relationship establishes connections between prims acting as a pointer or link between objects in the scene hierarchy. A relationship allows a prim to target or refer to other prims, attribute, or even other relationships. This establishes dependencies between scene graph objects. Now, how does it work? So, relationship stores path values that point to other scene elements when you query a relationship. Target OpenUSD performs path path translations. Can you hover over path translation? So a path translation is the automatic remapping of paths that happens when composition arcs rename prims. Huh, interesting. To map, and a path is a location identifier in USD namespace represented by SGF path class. Hmm.
Okay. So wait, it basically establishes a connection between prims that is pretty straightforward. It acts as a pointer or links between objects in the scene hierarchy that is pretty straightforward. Relationship allows prims to target or refer to other prims, yes. Attributes or even other relationship, yes. This establishes dependency between scene graph and objects. Scene graph and objects, cool. Relationships store path values that point to other scene elements. When you query a relationships target, OpenUSD performs path translations to map the author target path paths to the corresponding objects in the composed scene prims. To map author target paths. Okay, I think we need to understand what this line means over here. When you save a contact for mom, you aren't saving actual physical person inside your phone. You're saving a pointer, her number that tells the system where to find her. The authored path, the phone number, this is specific world address you wrote down originally in your scene. This might be world asset chair A. Okay, authored path is basically the path of that prim. Bro, how much parallel work are you gonna do?
Do, split this window over there. This one, and then we can do parallel. It's the
Mhm.
okay. Where we at? Wait, what the hell am I seeing right? Okay.
Here, let's read this.
So what we have over here is when you save contact for mom, you aren't saving her actual physical person inside your phone. Oh, you're saving a pointer, her phone number that tells the system where to find her. I see. I see. So the analogy, this is a specific address you wrote down originally in your scene. This might be world app here. The query pressing call when you want to use relationship example asking which chair is this table related to, and you're dialing that path translation, the switchboard. This is the clever part. Imagine your mom moves to a different city and gets a new house, but your phone system is smart enough to know that mom now lives at the new address without you having to update the contact. Oh, I see. That's what path translation is. And then hmm and then relationship doesn't drive. Okay.
Imagine your mom moves to a different city and gets a new house, but your phone system is smart enough to know that mom now lives in the new address about you having, uh, without you. How? In OpenUSD, if you move a chair from one folder to another, the relationship doesn't break. The system performs a path transfer. Oh, okay. Got it. So if the prim moves into a different layer, the path translation will kick in and it'll automatically change the authored path for that particular prim.
Yes. So basically, like it's modularized and it will auto detect
Yeah.
when it is moves here and there. Now I think wait where what the hell? Okay, so what do we have over here? So now let's go to Okay, relationships are robust patch translation. A key advantage over hard-coded paths. If a target premise patch changes due to editing. Okay, this is what basically it was saying over there.
Yeah, yeah,
And now
yeah.
and it also says that a relationship can have multiple targets, making them useful for grouping or collecting objects together. So I think relationship provides one to many relationship, like it's a one to many thing. Because it
Mm-hmm.
says that it can be useful for grouping or collecting objects together. So I think a relationship can be connected to multiple objects.
Mm-hmm.
For example, a material relationship might target all geometry prims that should use that material. Note that the relationship is an alternative type of property. Oh, okay. Relationship is also an property right now. To an attribute, unlike an attribute, it has no data type. Important thing to note. It
Mm-hmm.
is a way of declaring at creation time. The only use for property is to record linkage information. Conceptually, it is like an attribute whose data type is a link. This means you cannot use relationship to connect two already existing attributes. For that, you can use attribute connections. So can you hover over attribute connections?
Network like shader graphs.
Hmm. A connection is a type link between attributes that could represent data flow relationship in networks like shader graph. Oh, I see.
Okay. Relationships can have multiple targets, making them useful for grouping or collecting objects together. For example, a material relationship might target all geometry prims that should use that material. Note that the relationship is an alternative type of property to an attribute. Okay. Unlike an attribute, it has no data type. Unlike an attribute, it has no data type. It is always declaring creation or at creation time. That only uses the property for a property is to record linkage information. Okay. Conceptually, it is like an attribute whose data type is link. Yes, link like a linked list.
Wait, dude, you are echoing. Hold on. I think you should mute somewhere.
Oh wait. Yeah, I know where. Yeah, now
Yeah,
it's fine.
no, it's fine.
Yo,
Yo. Yeah, it's good. It's good. Now,
is it fine
I
now?
think. Is it fine now? Yeah, it's good. Oh, are you able to hear me? Yeah, it's good. It's good. It's good.
Okay.
Okay.
Cool.
Cool.
Conceptually, it is like an
Conceptually, it is
attribute
like
whose
an
data
attribute
type is
whose
a
data
link.
type is a
This
link.
means that you
This
cannot
means
use
that
a
you cannot use
relationship
a
to connect to
relationship to
already
connect to
existing
already
attributes.
existing
For
attributes.
that, you
For
can use
that, you can
attribute
use
connections.
attribute connections.
You cannot
You
use a
cannot use a
relationship to connect to
relationship to
already
connect to
existing
already existing
attributes.
attributes.
Attribute connection is a
Attribute
type
connection is a type
link between
link
attributes
between
that can
attributes that can
represent data
represent
flow
data flow
relationships in networks
relationships
like
in networks
shader
like shader
graphs.
graphs.
Working with
Working
Python,
with
here are a few
Python, here are a
Python
few
commands to
Python commands to
familiarize yourself
familiarize
as you work
yourself
with
as you work with
relationships. These can be
relationships. These
useful
can be useful
as you
as
establish
you
connections
establish
between
connections
different scene
between different
elements
scene
like
elements
materials
like
and
materials and
geometry.
geometry.
Bro, do you want to take a
Bro, do you
look
want to take
at
a
this
look at
plan
this plan
that it
that
generated?
it generated? Sure. Zoom in. Command plus. Command plus, brother. Command
Yeah,
plus plus.
wait.
Yeah, wait.
Ships to
Ships
artifacts
to
getting
Oh yeah,
loaded
we
into
can
the
definitely run a
network.
Linux container. Oh damn, I forgot about that. Select for blah blah blah. CMake for source build. Go down.
If you're using a
If
Mac
you're
OS,
using
you
a
can
Mac
still
OS, you
run
can still
USD,
run
but you will have
USDB,
to
but
build
you
it
will have to
yourself
build it yourself
using the
using the
OpenUSD
OpenUSD
repository.
repository.
Apple Silicon
Apple
ARM
Silicon
4 Gold
ARM
get
4 Gold
both
get
pieces
both
working
pieces
natively
working
with no
natively
Linux
with no
container
Linux
detour.
container detour.
Already verified
Already
toolkit,
verified toolkit,
LFS,
LFS,
UV,
UV,
Homebrew,
Homebrew,
CMake, all that
CMake,
shit,
all
blah
that
blah
shit,
blah.
blah blah blah.
Pixar,
Pixar,
OpenUSD clone.
OpenUSD clone.
Okay.
Okay.
Bro, look at this,
Bro,
what
look
it's
at this,
saying.
what it's saying.
Okay, so we are using UV. UV is a wait. Copy that, and I ask him that UV is a Python package manager, and can you explain, like, elaborate on this? Just ask him elaborate on this
Wait,
because
well,
UV.
Wait,
let me
well,
read
let
the
me
whole
read
thing
the
Uh,
whole
first.
thing
Like all
first.
the
Like
steps.
all the
I
steps.
think
I
it's
think
gonna
it's
clarify
gonna
down there.
clarify down there.
mhm.
USD view, but
USD
only a
view, but
view
only a
source
view
build.
source
Pixar's
build.
build
Pixar's
USD
build
is the
USD is the
supported path on
supported path on
macOS.
macOS.
Native USD.
Native USD.
USD view,
USD view
instance prefix
instance
build
prefix
output.
build output.
Follow
Follow
of
of
NVIDIA's
NVIDIA's
page.
page.
No macOS
No
specific
macOS
edits
specific
needed.
edits needed.
Get LFS
Get LFS
install.
install.
Follow.
Follow.
Git clone, UV run, brew install CMake, blah blah blah. Run Pixar's build script, UV create manage.
I think I'll do
I
this
think
on
I'll
my
do
own
this on my
time.
own time.
Mm-hmm. Dude, let's just let it run in the background, right? Just let it run in the background and we'll
No,
see what
bro,
it
because
does.
No,
it's
bro, because
gonna
it's
create
gonna
two new
create two new
repositories and
repositories
it's gonna
and it's
like.
gonna like.
So let it do, no?
Uh,
What's the matter? We will see.
Okay.
okay.
Bro, I'll have
Bro,
to
I'll have to
accept edits all
accept
the time.
edits all
No,
the
bro.
time.
We,
No,
we
bro.
need
No,
to
no,
We
no.
focus
need
on
to
You can
the.
focus
use
on
yes
the.
and use auto mode, dude. Yes and use auto
Bro,
mode.
it's
Bro,
still gonna
it's
ask
still
for a
gonna
lot
ask
of
for a
Just do
lot
permission.
of
it. Do it.
permission.
Do it. Do it. Do it.
Okay.
Okay.
And then we will see. Let's go back over there and focus on our code
Yeah.
base.
Yeah.
Okay. Note
Okay.
that
Note that
relationships are
relationships are
is an alternative
is an
type. Oh, yeah,
alternative
we
type. Oh
read
yeah, we
this.
read this.
Okay, so working with Python. So we have USG relationship dot get targets, and then we have
Set
USG
targets,
Set
add
relationship
target,
targets,
and
dot
add
set
remove
target, and
target.
targets.
remove target.
Hmm. Okay. Okay. I think let's go down. We can see more about those like
USD
examples.
USD
relationships
relationships
from collections
from
with
collections with
relationships.
relationships.
Relationships are
Relationships.
properties that store one or more target paths. You can author a relationship with create relationship, then later retrieve it with get relationship. Huh, interesting. So we can use create relationship to author a relationship, and then we can use get relationship to retrieve it, and then to inspect it we can use get targets. So now let's focus on the code base. So as we walk through the code base, we have created our new stage, and then we are loading our prem
Bro,
basically.
just
Bro,
explain
just
me. Yeah,
explain
this is
me. Yeah,
something I
this is
was not
something I
able to
was not
understand
able to
yesterday as
understand
well.
yesterday as well.
What,
What?
why is this
Why
world
is
X
this
form
world X
type hint
form
over
type
here?
hint over
And
here?
what, and
And what?
Dude,
then
that's
And
a
then
that dude that is the variable, and USD geom.xform is the type hint. So if you
okay.
don't use it, it's still gonna work. That is the type hint. Like if you copy it in the Gemini, it's gonna explain it to you. But USD.xform is just a type hint for the developers to understand. Okay, what is this meant for?
One of the most
one of the
fundamental
most
building
fundamental
blocks, you can
building
think of it
blocks,
as
you
a
can think of it
folder
as a
with
folder
GPS
with GPS
coordinates.
coordinates.
A folder with
A
GPS
folder with
coordinate
GPS
defines
coordinate
where
defines
things
where
are
things
by
are
itself.
by
USD
itself. USD
geom X
geom
form
X form
transform doesn't have
transform
a
doesn't
shape.
have
It
a
doesn't
shape. It
look like a
doesn't
chair
look
or a
like a
car.
chair or
Instead,
a
it
car.
defines a
Instead, it defines
point
a
on
point
3D
on
space
3D space
when you can
when you can
when you put
when you put
other objects like
other
a mesh or
objects like a
light
mesh
inside
or
an
light
X
inside
form,
an
they
X form.
inherit
They
its
inherit
position,
its
rotation,
position,
and
rotation,
scale.
and scale.
What does this
What does
mean?
this mean?
In a complex scene,
In a
you rarely
complex scene,
want
you
to
rarely
move
want to
thousand
move
individual
thousand
leaves of
individual
a
leaves
tree
of a
one by
tree
one.
one by one.
You put all
You put
leaf
all
meshes into
leaf meshes
USD
into
geom X
USD
form
geom X
called
form
tree
called tree
canopy.
canopy.
When you move that
When
X
you move
form,
that
every
X form, every
leaf moves with
leaf
it.
moves with
Okay,
it.
I think I
Okay,
get it
I
a
think I
little
get
bit.
it a little bit.
Namespace versus
Namespace versus
transformation. While you can use
transformation. While you can
basic
use
scope to
basic
organize your
scope to
file, a
organize your
scope
file, a
cannot be
scope
moved in
cannot be
3D
moved in
space.
3D
USD
space. USD
geom.x form is
geom.xform is
specifically
specifically
designed for
designed
objects
for
that need to
objects
be
that need to
placed or
be placed
animated.
or animated.
Oh, okay.
Oh, okay.
Efficient
Efficient
inheritance. Okay.
inheritance. Okay.
See, bro,
See,
look at
bro,
this. I
look at
was
this.
telling you
I
it's
was
gonna
telling
ask
you it's
for
gonna ask
more
for more
permissions.
Don't
permissions.
ask again, dude. It's gonna just ask you for a couple of
Bro,
commands.
Bro,
Do it,
yeah,
do it.
let's
yeah,
see.
let's see.
Let's go. Let's go. Let's go over here. If it asks, then we'll see. Cute.
Okay.
Okay.
Wheel X
Wheel
form.
X form.
OpenUSD. Okay,
OpenUSD.
namespace
Okay,
versus
namespace versus
transformation.
transformation.
Okay.
Okay.
Efficient inheritance.
Efficient
The parent
inheritance.
child
The
rule.
parent-child
OpenUSD
rule.
uses
OpenUSD
hierarchical
uses
system. If
hierarchical
you have
system. If
a
you
car
have
X
a
form,
RX form,
inside it you have a
inside it
wheel
you
X
have
form.
wheel
If a
X
car X
form. If
form
a
moves
car X
10
form
years
moves
forward,
10
the
years
wheel
forward,
X form
the wheel X
automatically
form
stays with the
automatically
car.
stays with the car.
However, you can still
However, you
rotate
can
the
still
wheel X
rotate
form
the wheel X
independently
form
to make it
independently to
spin.
make it spin.
Dude, where the hell are you going? You're just moving away from the concept that we're trying to focus on right now.
Bro,
Like
I was just
Bro, I
it's
trying
was
giving
to
just
you
trying
it's
to.
giving you extra information like
yeah, yeah,
over
yeah.
Yeah,
here.
Okay.
yeah, yeah.
I'm just
Okay.
trying
I'm
to
just
be
trying to
sure.
be
Okay. So
sure. Okay.
USD
Dude,
So
geom.x
USD
form equals to
geom.xform
USD
equals to USD
geom.x form
so
geom.xform
defines
what I'm
stage.
saying
defines
is
stage.
that is only a type hint. Like if you don't write usdgeom.xform, it is still gonna work. That's what I'm saying. If you just write world underscore xform, it's still gonna work. Because why? Because you are trying to add, like if you look at the line 12 or line
But we
9.
still need
But
to
we
use
still need to
USD
use
geom.x
USD
form dot define to
define
define the
to
Yeah,
stage,
we can.
define
right?
the
Yeah, we
stage,
need to
right?
use that over there, but we are not required to use usdgeom.xform over
Mm-hmm.
here because it's just a type hint. That's it.
Okay.
It's only for good coding practices.
Got it.
It
Got
doesn't.
it.
Got it, got it.
Right. Yeah. The most important thing is that one that is creating the X form and this and loading it into the stage.
Mm-hmm.
Mm-hmm.
So
So
then define a
then
sphere under
define a
the world
sphere
X
under the
form.
world X form.
Okay, so
Okay,
sphere is
so
USD
sphere
geom
is
dot
USD
sphere equals
geom
to
dot sphere
USD
equals to
geom dot
USD
sphere
geom
dot
dot sphere dot
define.
define.
And then
And then
this was
this was
stage
stage
and then world
and then world
X form
X
dot
form
get path
dot get path
dot append
dot
path
append
sphere.
path sphere.
world x
world
form
x
dot get
form dot
path
get
dot
path
append
dot
path
append path
sphere.
sphere.
Okay,
Okay,
this is the stage
this
and
is the
this is the
stage and
path,
this is the path,
right?
right?
Yes.
And
It's
then
all the
And
define.
same.
then define.
Yeah.
Yeah,
I'm
yeah,
just
yeah.
making
I'm just
sure, bro,
making sure,
because
bro,
I
because
did not get
I
it
did not
yesterday.
get it
That's why
yesterday.
I'm
That's why I'm
Hmm.
cube.
cube,
Then USD.
then
This is the
USD.
another
This is
type,
the
and
another
USD
type, and
geom dot
USD
cube,
geom dot
USD
cube,
geom dot
USD
cube dot
geom dot
define.
cube dot
Correct
define.
stage
Correct
world.
stage
Okay, and
world.
then it's
Okay,
the
and
same
then it's
thing.
the same
This
thing.
is the stage.
This is
This
the
is the
stage.
path,
This is the path.
and then
And
USD
then
geom dot
USD
xform
geom dot
API.
xform API.
Now what is
Now what
this?
is this?
This
Set.
is the
Set.
one that will basically load that, basically translate your object from on a certain axis, right? So we have our cube, so we are loading our cube, and then we are going to translate it. Dude, yes, just go down. You are gonna see the example. This
Yeah,
one.
I
Yeah,
know,
I
I
Cube.
know,
know, I know,
bro.
bro.
Are you trying to like just remember like by remember everything word by word? If you do that, dude, you won't be able to learn the concept at this point.
Cool. I'm
Cool.
just trying to
I'm
learn
just
the
trying to learn
syntax,
the
bro.
syntax,
Like,
bro. Like,
You have to understand the syntax, not learn it, dude. This is AI error.
okay.
okay.
Got it, got it.
Got it, got it.
USD geom xform
USD Geom
API.
Xform API.
Schema wrapper.
Schema
Okay,
wrapper.
so this
Okay,
is
so
the
this
schema
is the
wrapper over
schema
here.
wrapper over here.
USD
USD
geom.xform
Geom
API.
Xform API.
Cube.
Cube.
Instead of manually
Instead of
creating a
manually
complex
creating a
transformation
complex
matrix,
transformation matrix,
xform API.
Xform API.
Common API provides a
Common
simple
API
way to
provides a
handle
simple way
basic
to handle
movement,
basic
translate,
movement,
rotate, scale.
translate,
It is
rotate, scale. It
essentially
is
telling the
essentially
computer, I
telling
want
the
to talk
computer,
to
I
this
want to
cube
talk to this
prim
cube prim
using common
using
movement
common
tools.
movement tools.
Dot set
Dot
translate.
set translate.
What do you think
What
dot
do you
set
think dot
translate
set
does?
translate does?
It translates
Yeah.
over your specific axis that you're gonna define it inside that group.
Okay.
Okay.
Yeah.
Okay.
Okay.
And then
And then
basically it is a
basically it
command
is
to
a
move the
command to
object.
move the
The
object.
logic, it also
The
has a
logic, it
specific
also has a
attribute on the
specific
prim called
attribute on the prim
xform
called
dot
xform dot
xform op
xform
dot translate in USD
translate
layer.
in
This tells
USD
the
layer. This
renderer
tells
when
the
the
renderer when the
object's
object's
pivots point
pivots
should
point
live.
should live.
Okay. Set
Okay.
translate
Set
gf dot
translate
vec
gf dot
3D.
vec 3D.
What is this? A
What
3D
is this? A
vector
3D
coordinate
vector
5
coordinates 5
units.
units.
Okay.
Okay, okay, okay.
Double precision.
Double
Design
precision.
math
Design
systematic
math
skills or
systematic
uses
skills
high
or
precision
uses high
math by
precision math by
default to
default
ensure
to ensure
objects
objects
don't jitter
don't
when they
jitter
are
when they are
far away from
far
the
away
center.
from the center.
Take object
Take object
named
named
cube, look
cube,
at it
look at it
through the standard
through the
movement
standard
lens
movement
and set its
lens and
position
set
to be
its
5
position
units
to
to
be
the
5
right.
units to the right.
Take the object name
Take the
cube,
object
look
name
at
cube,
it
look
through standard
at through
movement
standard
lens.
movement
Okay.
lens. Okay.
Bro, look at
Bro,
this.
look at this.
Look at this.
Look at
Again,
this.
Yes.
permission.
Again,
Just do
permission.
yes.
I know,
I
bro. I
know,
know
bro.
I
I
need to
know
do
I need
It's
to
yes,
do
but
fine. It's
yes,
fine.
but
Chalo,
yeah.
chalo. Move,
yeah.
move. Hmm.
Create typeless
Create
container
typeless
for the
container
group.
for the
Group
group.
equals to
Group
stage dot
equals to
define
stage dot
prim model
define
group.
prim model group.
Okay, so they are
Okay, so
creating
they are
another
creating
container
another
called group.
container called group.
But in this, they are not using an X form. We'll take a look at that. They are not using an X form, and it becomes a typeless container at this point.
Oh, this is
It's
a
just
Oh,
typeless
this is a
container.
typeless
Yes,
container.
because they're
Yes,
not
yeah.
because
using
they're not
USD
using
geom dot
USD
x
geom
form.
dot x form.
They are just
They are
doing
just
stage
doing
dot define
stage dot
prim.
define prim.
Define
Yes.
prim.
Define prim.
Yes.
Typeless container.
Typeless
But
container. But
over here,
over here,
okay, just stage
okay,
is
just
different
stage
over
is
here,
different
and
over
this is
here,
a
and this is
different
a different
So
stage.
stage is
stage.
gonna be the same. Like you're gonna define it in the stage because
Yeah,
stage
yeah,
is
yeah.
the
Yeah, yeah,
root
yeah.
layer, right?
Okay.
Okay.
Stage dot define
Stage
prime.
dot define
Yes,
prime.
because it's a
Yes,
root layer.
because it's a
Define the
root layer.
relationship.
Define the relationship.
Group dot create
Group dot create
relationships.
relationships.
Members
Members
custom
custom
to
to
group dot create
group dot
relation.
create
Okay, so
relation.
now
Okay,
we are
so now
using
we
dot
are
create
using dot create
relationship over
relationship
here.
over here.
Yes.
They didn't
They
mention it
didn't
create
mention it
relationships
create
over
relationships
here,
over
but
here, but
okay.
okay.
But okay.
Dot create
Dot
relationship
create
I think
relationship
members custom
members
just
to
copy
custom
this
to
into over here. I think we need to understand what elaborately a bit more.
The code is the
The
part
code
where
is the
you
part
actually
where you
select
actually
which
select
people
which
are
people
added to a
are added
specific
to a
group chat.
specific group
Okay.
chat. Okay.
So they are
So
basically
they are
defining a
basically
group
defining
over
a
here.
group over here.
And in that
And
group,
in
they
that
are, I
group, they
think,
are, I
adding
think,
sphere
adding
and
sphere
cube
and cube
by doing dot
by
set
doing
target.
dot
Oh,
set
I
target. Oh,
understood.
I
Okay.
understood. Okay.
The action
The
this creates a
action
new
this creates a
empty
new
link
empty link
name
name
members.
members.
Custom equals to true.
Custom
This
equals to
tells
true. This
OpenUSD
tells
that members
OpenUSD
is
that
under
members is
standard
under
built-in
standard
settings like
built-in
color or
settings like
size.
color or size.
So this is
So this is
custom equals to
custom
true
equals to
means that
true
this
means
is
that
like
this is
a
like a
okay.
okay.
But a link
But
you
a
are
link you are
inventing for your own
inventing for your own
organization. A link
organization.
that
A
we are
link that we
inventing.
are inventing.
The analogy you're
The
creating a new
analogy you're
folder in
creating a
your
new folder
contacts
in your
list, naming
contacts
work
list,
friends,
naming work
dot set
friends, dot
targets.
set targets.
This is the
This
assign.
is the
Okay,
assign.
over
Okay,
here
over
if it
here,
was
if it
telling us
was
what dot
telling us
set
what
targets
dot set
does.
targets
So
does, so
set the target
set the
path for
target path
relationship.
for relationship.
So
So
now over
now
here,
over
the
here,
action is
the
this
action
assigns
is
a
this
command that
assigns a
defines
command that
who
defines who
relationship points to.
relationship points to.
Analogy is the
Analogy
moment
is
you
the
click
moment you
add
click
member
add
and select
member
people
and
from
select
your
people
list.
from your
Okay,
list.
so this is
Okay.
what the
So this
set
is what the
targets
set
does. It
targets
just
does. It just
basically lets you
basically
select
lets you
what
select what
prims you wanna
prims
add
you
to a
wanna add to
relationship
a
link.
relationship link.
Yes.
Sphere dot get path action.
Sphere.get
This
path
provides the
action. This
address
provides
of
the
the
address of the
objects that you want to
objects that
link.
you want to link.
Hmm.
Hmm.
Okay.
Okay.
Now
Oh, so
Now
basically we have created. Okay, if we add
we basically
more.
are
we
creating
basically
a
are
group
creating
of
a group
relation,
of
like
relation, like
we're
If we add
defining a
more,
defining a
relationship.
relationship.
yeah, I'm saying that if we add more objects into that, I think it will we can create more relationships with each other accordingly,
Yeah.
right? Because that's an array, right? So we can add n number of
Yeah, yeah, yeah.
objects in there.
Yeah, so like
Yeah,
sphere
so like
dot get
sphere
path,
dot
then
get
cube
path,
dot
then
get
cube
path,
dot
and
get
then
path, and
triangle
then
dot
triangle dot
cone dot get
cone dot
path.
get
So all
path.
of
So
these would
all of these
be
would
defined
be
inside
defined
that
inside that
link of
link of
relationships.
relationships.
And then
And
list
then
relationship
list
targets.
relationship targets.
Members
Members
rel
rel
equals to group dot
equals to group dot
relationships.
relationships.
Group dot get
Group
relate.
dot
Okay,
get
so
relate.
this
Okay, so
this relationship
this
link is
relationship link
called
is
members.
called
This is
members.
the
This
name we have
is the
given it
name we
over
have
here.
given it over here.
And
And
then
then
once
once
members
members
underscore
underscore
rel equals
rel
to group
equals to
dot
group
get
Like
dot get
relationship.
relationship.
it's gonna load what is the relationship we have, and then it's
Hmm.
gonna print the members. Oh, I see now.
For
Oh, I
p
see
For
now.
member
p
dot get
member
target
dot get
solver.
target
Okay,
solver.
yeah.
Okay, yeah.
Makes sense. So
String p
once we
String
created
for
the
p
p
for
in
p in
members
members
rel get
rel get
targets.
targets.
that's just like typecasting and all that shit.
Yeah.
But
Yeah.
I'm trying to understand. Okay, so get targets also gives you an array. That's what I'm trying to. That's what it means. So when we use get targets, it's gonna give us an array back, and then we can basically iterate through that
Oh,
array.
like
Oh,
here.
like
Hmm.
here.
Get the
Yeah.
target
Get
of
the
the
target of the
paths
path
of
of
relationship.
relationship.
Cool. Got
Cool.
this.
Got this.
Relationships,
Relationships,
members, rel,
members,
group dot
rel,
get
group dot get
relationships. Okay.
relationships. Okay.
Group members
Group
are
members are
string. Okay,
string.
so this
Okay, so
basically
this
gives
basically
the
gives the
path
path
of
of
sphere and cube.
sphere and cube.
Got it.
Got it.
So this
So this
defines an
defines
form
an
board,
form
an
board,
X
an
for
X of
sphere, cube,
sphere, cube,
and then group.
and then group.
Got it.
Got it.
Got it.
Got it.
Example 2.
Example
Come
two.
on.
Come on.
Using a built-in
Using a
relationship
built-in
proxy
relationship
prim,
proxy prim,
many built-in
many
schemas
built-in
expose
schemas
relationships
expose
dot
relationships
use
dot
USD
use
geom
USD geom
imageable
imageable.
has proxy
Has
prim,
proxy
which
prim,
points at
which
a high
points
cost
at a high
prim to a
cost prim,
lightweight
a
proxy.
lightweight proxy.
What does this
What
mean?
does this
Many
mean?
built-in
Many
schemas
built-in
expose
schemas
relationship
expose
USD.
relationship USD.
Yes. Don't ask again. Wait, why don't you have auto mode on? Shift tab. Shift tab. Shift tab. Wait, why is it? Oh, I think auto mode is disabled for some reason.
Got it.
Got it.
Come on, bro.
Come on,
Do
bro.
this.
Read
Oh,
this.
okay. So let's focus on example two using a built-in relationship proxy prim. Many built-in schema expose the relationships. All right, USD geom dot imageable has proxy prim, which points to a high cost prim to a lightweight proxy. So once we walk through the code base, okay, so we have defined a high cost spear prim and then a low cost spear prim. Oh, a low cost cube over here. And then what we did was we used USD geom dot imageable high and
Wait.
got the purpose. Okay, yeah, we need to definitely understand the 14th and 15th line.
Wait.
Wait,
Define
define
high
high
is.
is.
Okay, so we
Okay, so
defined a
we
sphere
defined a
called
sphere
high
called
res
high res
as
as
append like
append
as
like
path,
as
and then
path, and
proxy
then proxy
as path
as
for
path
cube.
for cube.
And this is high,
And this
this
is
is
high,
low for
this is
some
low for
reason.
some reason.
But how?
But how?
It's just a definition.
Definition, right? Like
Definition,
this is
right?
just a
Like this is
name.
just a
It's
name.
not a
Yeah,
It's
that's a
property.
not a
name.
property.
No, that's a name. That's it. It's a
Okay.
variable.
Okay.
Yeah, variable.
Yeah, variable.
USD geom dot
USD geom
imageable
dot
high
imageable
get
high get
purpose
purpose
attribute
attribute
set
set
render
render
imageable low
imageable low
get.
get.
Oh wait.
Oh wait.
So
So
only
only
the
the
low
low
cost
cost
cube prim
cube prim
is
is
draw prim,
draw
and then
prim, and
USD
then
geom
USD geom
high dot
high
computer
dot computer
returns USD
returns
dot
USD
prim.
dot
Print
prim.
preview
Print
should
preview
draw
should draw
world
world
proxy.
proxy.
Author
Author
USD dot
USD dot
imageable
imageable
high
high
get
get
proxy prim
proxy
rel
prim rel
dot set
dot
target
set
slow
target
get
slow
path.
get
What the
path. What
fuck
the
does that
fuck does
mean?
that mean?
Yeah, I need to
Yeah, I
ask
need to
this.
ask this. Gemini.
Okay, what does it say? The code. Okay. Render prim. This is the lead actor. Hi. They look perfect, but they're expensive and heavy to handle on set all day. The proxy prim. This is the stun double. They are a simple version used for setup. Okay.
Wait, I
Huh.
didn't
Wait,
get
I
it.
didn't get it.
One second.
One
Dude,
second.
you remember yesterday we were learning about proxy prim and how proxy prim is used to just render some specific certain components instead of rendering all the components or all the prims. If you have, let's say, a complex set of prim network and you're trying to load multiple objects, right? But you just want to test out, okay, the object that you have created works flawlessly, instead of rendering everything because it's going to be compute intensive. So for that we use proxy prim. That's what it says. So our render prim, the high one, is the real one that we want to render, but our low one, that is the proxy prim, is our stun double, like basically a simpler version that is only
Mm-hmm.
used for setup and testing.
Okay.
And when we render it, it's going to render as same but at a lower quality. so that our compute does not like we don't consume on our compute a lot.
Mm-hmm. Okay.
Okay.
High-res models
High-res
which are
models
slow
which
to
are
load,
slow to
and
load,
low-res
and
models which
low-res
are
models which are
fast.
fast.
This logic tells the
This
computer
logic tells
which
the
to show
computer which to
when.
show
Current
when.
logic, the
Current
movie
logic,
star
the
and the
movie
stunt
star
double,
and the stunt
render
double,
prim
render
highs,
prim
the lead
highs,
actor
the
that
lead
they
actor
look
that they
perfect,
look
but they're
perfect, but
expensive
they're
and heavy to
expensive and
have
heavy to
on set
have
all
on
day.
set all day.
Proxy prim low
Proxy
is the
prim low
stunt
is
double.
the
They are
stunt double.
simpler
They are
version
simpler
used for
version
setup and
used for
testing, so
setup
the
and
lead
testing,
actor
so the
doesn't
lead
get
actor
tired or
doesn't
the
get
computer
tired or the
doesn't lag.
computer doesn't lag.
Signing the rows
Signing the
USD
rows
geo
USD
imageable
geo
high
imageable
dot get
high dot get
purpose
purpose
attribute set
attribute
render.
set render.
Simple terms, you are
Simple terms,
labeling
you
the
are
high res
labeling the
model
high-res
as the
model
final
as the
version
final
and low
version
res
and
model as the
low-res
draft
model as a
version
draft
proxy.
version proxy.
I
I
see.
see.
Oh.
Oh.
So whenever we
Okay.
are
So
like
whenever we are
testing it
like
out,
testing
then
it
it's
out,
gonna
then
render
it's
the
gonna
proxy
render the
prim.
proxy prim.
No, but we have to first link it. That is what. So
Yeah, yeah.
Yeah,
But
yeah. But
when
usd.geom
once
image
once
high dot get proxy prim rel. I don't know what does this do. And then set
whoa,
target for low
where
and get fast.
where
The second one, second linking them together.
wait, I
wait.
think
I think
that's why
that's why
we are
we are
establishing the
establishing the
relationship between
relationship
them.
between them.
What? No, we haven't defined any relationship over here
Dot set
because
Dot
targets,
set
bro.
targets, bro.
but
Look
wait,
at
dude,
Look
this.
this
at
is this. No,
this.
no, this is you. Are we like okay? But what does get proxy prim rel does? Get proxy prim rel.
Wait,
Wait,
wait.
wait.
Let me read one
Let me
second.
read 1 second.
So we
So
assign
we
the
assign the
role
role
over
over
here
here
usd.geom usdgeom.imageable high
imageable
dot get
high dot get
purpose
purpose
attribute
attribute
dot set
dot
render.
set render.
Okay.
Okay.
High res model
High
and the
res
final
model and the
version,
final version,
and imageable
and
high means
imageable
the
high
final
means the
version,
final version,
and
Yes.
imageable
and imageable
low res
low
model as the
res
draft
model as a
version.
draft
Linking them
version. Linking
together,
them together,
usdgeom.imageable high
usdgeom.imageable
dot
high
get
dot
proxy
get
prim
proxy
rel
prim rel
dot set
dot set
targets low
targets
dot get
low dot
path.
get path.
Oh,
Oh,
we are just
we are
linking it
just linking
together.
it together.
Oh,
Oh,
I
I
get
get
it,
it, I
bro.
get it,
Look at
bro.
this.
Look at this.
Low,
Set
Low,
target low dot get
just
path.
look at this.
just
Low
look at
dot
this.
get
Low dot
path
get path
means it's getting
means
this
it's
low,
getting this
like the
low,
path
like
for
the path for
this
this
proxy,
proxy,
because this is
because
low
this is
and
low
this is low,
and this is low,
right? And
right?
then set
And then
targets is
set targets is
basically grouping them
basically grouping
together, I
them together,
guess,
I
over
guess,
here.
over here.
Target paths for
Target paths for
relationship,
relationship,
and
and
then get
then get
proxy
proxy
prim
prim
rel.
Mm-hmm.
rel.
Yeah, this
Is
is what I'm
Is
trying to understand. I don't know about this.
okay. This
okay.
is
This
what I
is
think
what
it
I think
should be
it
doing
should be doing
for
for
author the proxy
author the
link
proxy
on the
link
render
on the
prim. I
render
think this
prim. I
is the
think
one
this is
that they
the
are
one that
using
they are
to
using
link it
to
together.
link it together.
But
But
wait,
wait,
set the
set
target
the
paths for
target
a
paths for a
relationship.
relationship.
Dot set
Dot set
targets.
targets.
US
US
relationship.
relationship.
Oh,
Oh,
this is
this
what
is
we use
what we
to
use to
define the proxy
define the proxy
relationship.
relationship.
This is just the
This is
function
just
that
the
we use
function
to
that we
define the
use to
proxy
define the
relationship.
proxy relationship.
Oh, that's a function that we use to define proxy relationship with imageable high.
Yeah.
Yeah.
Like you can use
Like
it
you can
for
use
not
it
only
for not
imageable
only
high, I think
imageable
there
high, I
might
think
be
there
render
might be
UC as
render
well,
UC
because
as well,
it's
because
just
it's just
you see over
you
here
see over
like
here
they're
like
doing
they're doing
USD
USD
relationship dot set
relationship dot set
targets.
targets.
Mm-hmm.
So this is
So this is
what
what
USD
USD
relationships. This is
relationships. This
dot
is dot
get
get
proxy prim
proxy
rel
prim rel,
and then dot
and
set
then dot set
targets.
targets.
So this is just
So
the
this is
function
just the
that
function that
establish a
establish
relationship
a relationship
between
between
for the
for
proxy.
the proxy.
You are telling the
You are
higher
telling
res
the
model,
higher res
hey, if
model,
the
hey,
computer
if
is
the
struggling
computer is
or
struggling
I'm
or
just looking
I'm just
for
looking
at a
for at
preview,
a preview,
use this low res
use this
model
low
as
res
your
model
stand-in.
as your
You've
stand-in.
officially
You've
linked the
officially
stunt
linked
double
the
to the
stunt double
actor.
to the
Yeah, I
actor.
think
Yeah,
that's
I
what
think
this
that's what
means.
this means.
I get it.
I get it.
So,
So,
okay.
okay.
Get proxy
Get
prim
proxy
rel.
prim rel.
Okay, tools
Okay,
that
tools
honor
that
proxy
honor
prim
proxy
should
prim
draw the
should draw the
proxy in
proxy
preview.
in preview.
Tools that
Tools
honor
that
proxy
honor
prim.
proxy prim.
Oh, okay. Compute proxy prim. Oh, that's easy.
Yeah,
So
draw.
Yeah,
basically,
draw.
Yeah, equals
so
to
Yeah, equals
USD
to
dot
USD dot
imageable.
so
imageable.
Compute
yeah, and
proxy
then
Compute
prim.
proxy
Returns
prim.
so
USD dot
Returns
prim.
USD dot prim.
so yeah, so in the above in the line above, we basically linked our high with our
Too
proxy,
low.
and then
Too
we're trying
low.
to
Yeah.
compute. Sorry, with the low, and then we're trying to compute the proxy out. Okay.
Mm-hmm.
And okay, oh, I
If
see.
draw
If
prim,
draw
else
prim,
high
else
dot get
high
path.
dot get path.
Now this is like hey, draw else I don't get path. Oh, draw prim. Okay, if draw prim else I don't get path. I think if draw prim is able to render it, then it will render. If not, then it will just give you the path. Should draw. Preview should draw. Hmm. And then we get. Hmm. Oh, okay, okay. Oh, I see. It's so it's responding with the proxy path instead of the real path. Okay. Yeah. Yes. I can see it. I can see it. In line second, we have appended the proxy path. Like, you can take a look at the line second. Did you see it?
Yeah, right.
Yeah, right.
Second line. You can see it where we appended the proxy path, and then we are getting the proxy path instead of the high path.
This one.
This one.
No, no,
Oh,
second
this
number
Oh,
line.
one.
this one.
Yeah. Take a look at like what we are appending into the path. We are
Yeah, yeah,
appending
Yeah,
proxy,
yeah,
proxy.
right?
Yeah,
proxy.
yeah.
Yeah,
Right,
yeah.
and then once we have linked the proxy to our high is showing that path instead of the path that high should show. So if you don't link it, I think it will show world slash render. Since we have linked it as a proxy prim, it's showing us slash world slash proxy over here.
Mm-hmm.
Mm-hmm.
Okay.
Okay.
I'm just
I'm
able.
just able.
I'm just trying to
I'm just
understand.
trying to
Preview
understand.
should
Preview
draw
should draw
string
string
draw prim
draw prim
zero
zero
index
index
dot get
dot
path.
get path.
If draw
If
prim
draw prim
else dot
else dot
else high
else
dot
high
get
dot
path.
get path.
Got it.
Got it.
The
The switch
switchboard.
mode.
Okay, the
Okay,
switchboard
the
testing
switchboard
link draw
testing link
prim
draw
with
prim with
this
this
as
as
I'm currently
I'm
in
currently
preview
in
mode.
preview
Which
mode.
version
Which
should I
version
actually
should I
draw on
actually draw
screen?
on screen?
If the link
If the
word
link
it return
word
low
it
res
return low
path.
res
Oh,
path.
so this is
Oh,
the
so this
code
is the
to
code
show
to
that
show
this is a
that this is a
preview.
preview.
I'm currently
I'm
in
currently
preview
in
mode.
preview mode.
Okay, which version
Okay,
should
which
I
version
actually
should
draw
I
on the
actually
screen
draw
if
on
the
the
link
screen
is
if the link is
working?
working?
It works
It
smoothly
works
without
smoothly without your
Okay.
okay.
So this should
So
have been
this should have been
a
a
sphere, but
sphere,
since this
but
is a
since this
proxy
is a
prim, this
proxy
is
prim,
a
this is
cube.
a cube.
Yes. No. It was
Yes,
Yes,
wait. Oh, hold on. It was. Oh, okay.
because this is a
because this
proxy
is a
prim, it's
proxy prim,
printing.
it's
Yeah.
printing. Yeah.
My bad. You are saying correct.
If draw
If
prim,
draw
is there a
prim,
valid
is there a
extendable
valid
link?
extendable link?
Yes, there
Yes,
is.
there is.
If yes, give
If
me the
yes,
address
give me the
of that
address
low
of
res
that low
proxy.
res
Yes,
proxy.
else get
Yes,
high
else get
path.
high
If
path.
no,
If
then the
no,
system
then the
can just
system can
find the
just
original.
find the original.
Convert that
Convert
address
that
into
address
readable
into
piece of
readable
text
piece of
string.
text
Show me the
string.
final
Show me the
decision and
final
the comment.
decision and the
Yes.
comment.
Okay, I
Yes.
understand
Okay, I
this. We can
understand
move
this. We
forward.
can move
Example
forward.
three. Come on.
Example three. Come on.
Come on. Material building binding is encoded
One
as a
second,
One second,
bro.
relationship.
bro.
What is this
What is
doing?
this doing?
Yes, don't ask again.
UV run.
UV run.
And persist
And persist
USD
USD in
env vars
ENV var in
ZSHRC.
ZSHRC.
Mm.
Yeah.
Yeah.
So from PXR import. Okay, wait.
Wait, bro. What
Wait,
is
bro.
Material
this?
What is this?
binding is encoded as a relationship named material binding that targets USD.material, the USD.material binding API, authors and read this relationship. Here, green mat is bound to two cubes and red mat is bound to one cube. Can you scroll down? More, more. Yeah. Oh, green and red. Oh, I see. These are the cubes that he's talking about. Okay, go up. Hmm. All right, let's go through the code. Okay, we have defined the stage and then we have defined cube 1, cube 2. Okay, and then we are translating the cubes over the x-axis 500.
Yeah.
Yeah.
And then
Yeah.
again the cube 3 is also translated 5 points ahead of the second cube. So
Yeah.
that is the third cube. And now looks. Again, we have created a typeless container. Can you
Mm-hmm.
search what is the use of typeless containers? So, okay, a typeless container often created by is a prim that has no specific type of schema.
Attached to it.
Attached to it.
Okay.
I know that,
I
but
know
why
that,
are you
but why
using
are we
it? Just
using
like you
it? Just like
use
you
folders to
use
keep your
folders to
desktop
keep your
clean,
desktop
you
clean, you
use typeless
use
containers to
typeless
group
containers to
related.
group
Oh,
related.
typeless
Oh,
container
typeless
is just
container is
to
just
group
to
items
group items
together for
together for
relationships.
relationships.
Yes.
The
The
looks
look
prim is
prim
typeless
is typeless
container.
container.
Yeah.
Yeah.
Is a typeless
Is a
container that
typeless
used to
container that
hold
used
all
to
the
hold all
materials
the
green
materials
mat, red
green mat,
mat.
red mat.
Without it,
Without it,
all your
all
materials and
your
geometry
materials and
would
geometry would
be in one
be
long
in
messy
one long
list.
messy list.
You can collapse
You
all
can
looks
collapse all
folders
looks
and keep
folders
your
and keep
scene
your scene
read tidy.
read tidy.
I
I
see.
see, I see.
Very useful.
Very useful.
So all of
So
this
all of this
is
is
going to be
going to
in the
be in the
looks
looks
container.
container.
Yeah. So now let's create a simple green material. Oh, I see now. Okay, so from I think till now we had a rock prim.
Yeah.
Yeah.
Right now we are wrapping the prim into a material.
Mm-hmm.
Mm-hmm.
So we are using USD shade library to
Dot
and
Dot
material.
dot
material.
material to wrap it up.
Define a
Define a
like a
like a
property
property
that
that
is
is
it's in
it's in
No,
stage,
no, 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 no.
stage
So,
and
so
then
and
what?
then
Yes. Wait. Okay. What the hell? Okay, go down. Green mat. Okay. So okay. We have created
bro, why
bro,
is
why
this?
is
Why can't
this?
I
Why
close
can't I
this
close
tab
this
over
tab
here?
over
don't
here?
because you have
Oh wait,
Gemini
Oh
open.
wait,
You
no,
have Gemini
no,
open.
because
because
You have Gemini open.
okay,
Yes.
okay.
bro, still
Bro, still
look at this.
look at this.
NVIDIA.
Fucking
Fucking
NVIDIA, bro.
NVIDIA, bro.
Oh, what the
Oh, what the
fuck?
fuck?
Okay,
Okay,
come on.
come on,
We're
come on.
almost
We are
done,
Okay.
bro.
almost done,
This
bro.
is just the
Okay.
This
last
is just the
example.
last example.
Yes, yes, yes. So we have green. Okay, now I'm trying to imagine, right? Wait. So we have created a looks, and then we are trying to create a path. We have already defined a staging up over there with world, and we already have cubes. But cubes were also appended in the world.
Wait,
Wait,
wait.
wait.
Oh, but we are defining a typeless prim over here. Yes, we are defining a typeless prim. That's why it's gonna be different. Okay, okay, makes sense, makes sense, makes sense. It's a typeless prim. Okay, so we have material USG material dot define. We are defining a material and then passing the stage. Why are we passing stage? Oh, okay, stage looks dot get path dot append green scroll horizontal scroll towards right green mat. Okay, so we have a stage and then we are putting our looks inside that. So we have our big prim stage layer and then we are putting our typeless container in that stage. Won't it?
Wait, let me
Wait, let me wait,
wait. I
wait,
think
wait.
I
I
get it.
think I get it.
So
So
we just
we
okay,
just
we'll
okay,
take a
we'll
step back.
take a step
We
back.
defined a
We
typeless
defined a
container,
typeless container,
right?
right?
Mhm.
And then
And then we
this is
are
a
this
type
is
int
a type in
USD shade
USD
dot
shade
material.
dot
This is a
material. This
variable
is a
green.
variable green.
And where
And
is this green
where is
coming
this
from?
green coming
USD
from?
shade dot
USD shade
material
dot
dot
material
define
dot define
stage
stage
looks dot
looks
get
dot
path
get
append
path
path
append
green
path
mat,
green mat,
right? Green
right?
mat is
Green
something
mat
that
is
is
something
already
that is
defined
already
in
defined
Yes.
in
USD
USD
shade dot
shade
material
dot material
API
API
schema
Yes.
API,
schema
right?
API, right?
And
Yes.
then
And
so
then
this is
so
where
this is
now
where
green is
now
stored
green is stored
over here.
over
Mhm.
here.
Now green
Now
PS
green PS
is
Mhm.
is
equal to
equal to
USD dot
USD
shader
dot
dot
shader
define
dot define
Mhm.
stage
stage
green dot get
green dot
path.
get
So
path.
this
So
path
this path,
like the above
like
one
the above one
over here,
over here,
and then dot
and then
append
dot
path
append path
of preview
of preview
surface. Now preview
surface. Now
surface is
preview
another
surface is
thing
another thing,
which is
Mhm.
which
already
is
defined
already
inside
defined
USD
inside
shader
USD
dot
shader dot
USD shade dot
USD
shader
shade dot
schema
shader
API,
schema API,
right?
Mhm.
right?
And then
And then
after that,
after
green
that, green
PS dot
PS
create
dot create
ID
ID
attribute
attribute
USD preview
USD preview
surface. Okay.
surface. Okay.
Now
Now
I
We
don't
have
know
I
created
don't
an
know
ID
what does
attribute.
this
what
do?
does this do?
Create ID
Create
attribute. What
ID
does this
attribute.
do?
What does this do?
So I think it is basically creating a mapping of the attribute that okay, this is the USD previous of it. Just copy it in the Gemini. I think.
Bro, wait. I
Bro,
think
wait. I think
I understand the
I
first two
understand the first
lines,
two lines,
and then
and then
this is just
this is just
create
creating create
ID at
ID at
I'm
ATRR.
confused
ATR.
that is this a predefined value USD preview surface?
Yeah, this is a
Yeah, this is
predefined
a
value,
predefined
bro.
value,
Because
bro.
you see
Because
over
you
here,
see over
green
here,
mat is
green mat is
predefined, append
predefined,
path for
append
Uh,
preview
path for
surfaces
preview
is
surfaces is
predefined.
predefined.
This append
This
path is
append
coming
path is
from
coming
USD
from
shader,
USD
like
shader,
USD
like
shade dot
USD shade
material
dot
schema
material
API.
schema API.
That's what I
That's
believe.
what
Like
I
we're
believe. Like
obviously
we're
gonna
obviously
copy this
gonna
in
copy
Gemini
this in
and
Gemini and
ask it again,
ask it again,
but I'm just
but
trying
I'm
to
just
see
trying to
create
see create
ID ATT.
ID
Okay, let
ATT.
it
Okay,
be.
let it be.
What does the next
What
line
does the
say?
next line say?
Green PS
Green
create
PS create
input
input
diffuse color
diffuse color
SDF
SDF
value
SDF
type
value
names
type
dot
names
color
dot
3f
color
set
3f
gf
set
vec
GF vec
3f
3f
0. So this
0.
is
So this is
RGB,
RGB,
right?
right?
So this
So
is
this is
red is 0,
red is
green is
0,
1,
green is
and B
1,
is
and
0.
B is
So
0. So
this is
this
setting
is
the color
setting
to
the color
green,
to green,
this part.
this
And then
part. And then
SDF dot
SDF
value
dot
type
value
names.
type names.
Uh,
no, I don't think so. That's green.
bro, this is
Bro,
green
this is green
RGB, bro.
RGB,
Red,
bro.
green,
Red,
blue.
green,
So
blue. So
red is 0,
red is
green
Oh,
is
0,
1,
green
blue
is
okay,
is
okay.
1,
0.
blue is 0.
Okay,
And
okay, I
then
get it
And
now.
then
SDF dot
SDF dot
value type
Value.
value
names
type
color
names color
3f
3F
diffuse color
diffuse color
create input.
create input.
Okay, and then what
Okay,
is
and then
happening?
what is
Green
happening?
dot create
Green dot
surface
create
output
surface output
Okay,
Okay,
create surface
create
output
surface
and
output
then
and
connect
then connect
to source
to
green
source
PS
green PS
connectable API
connectable API
surface.
surface.
So create
So
simple
create
green
simple
material
green
for
material
preview.
for preview.
Okay.
Okay.
I think this is
I
just
think this is
defining the
just
color,
defining the
bro.
color, bro.
Like
Like
this part.
this part.
And
Yeah.
then,
And then,
okay.
okay.
Oh, we are basically defining the complete green material. Wait. I get it. I get it. I get it now. I get it
And then
completely.
And then
similarly, there
Okay.
you're
similarly, there
doing that
you're
for
doing
red.
that
Yes.
for red.
And then
And
Why
bind
did
then
you?
materials
bind
to trims.
materials to
USD
trims.
dot
USD
shade
dot shade
material
material
binding API
binding
apply
API
cube
apply
1
cube one.
get prim
Get
bind
prim
green.
bind green.
Cube 2
Cube
bind
2
green.
bind
Cube
green.
3
Cube
bind
3
red.
bind red.
Oh, I
And
see. I
then
see.
And then
And then we are just loading them, rendering them.
for prim
for
in
prim
cube
in
1 cube
cube
2
1
cube
cube
3
2
mat
cube 3
equals to
mat equals
USD
to
dot shade
USD dot
material
shade material
binding
binding
API prim
API
dot
prim
get
dot
direct
get
binding.
direct binding.
uh
Uh,
Oh, look at
oh,
this. Look
look
at
at
the
this.
output.
Look
I
at the
understand
output.
it
I
now.
understand it now.
They're linking the
They're linking
material
the
shade
material
of
shade
green
of
mat to
green
cube
mat to
1
cube 1
and
and
then
then
green mat to
green
cube
mat to
2
cube 2
and then
and
red mat
then
to
red
cube
mat to
3.
cube 3.
Like over here.
Like over here.
They're just
They're
binding it
just
over here.
binding it over here.
And to
And
bind
to
it,
bind
they're
it,
using
they're
this dot
using this
bind, I
dot bind,
guess.
I guess.
Remove
Remove
target, add
target, add
target, but
target, but
they haven't
they
defined it
haven't
over
defined
here
it
for
over
some
here
reason.
for some reason.
This is a for
This is
loop
a
that's
for
just
loop that's
printing
just
out the
printing
binding
out the binding
information
information
for the
for
cube.
the cube.
And
And
okay.
okay,
But why
but
does this
why
need to
does
be
this
so
need to be so
complicated? Like why
complicated? Like
does
why does
this
this
defining the
defining
green
the
material
green
need to be so
material need to be so
complicated?
complicated?
Because USD is just a set of layers. You have to, like, the thing is, we are gonna wrap it in more complex materials in the future.
Mm-hmm.
This is just a demo.
Mm-hmm.
So I think as we move ahead in understanding how OpenUSD works, we will get to know more about it. Why is this more such? Why is it that complicated, and what are the other things that we can do? Because this library diffuse color, I don't know that. And then what else do we have? USD preview surface.
I think as
I
we
think
start
as we start
working with the
working
project,
with
I
the
think we'll
project, I
start
think we'll start
remembering the
remembering the
Yeah.
schema
schema
APIs more.
APIs more.
Like I already
Like I
remember
already remember
USD
USD
form.
form.
Like every time
Like
we need
every
to
time we
define a
need to
stage, we
define a
need to
stage, we
load
need to
USD
load
form schema
form
API.
schema API.
And then
And
now every
then
time we
now
need
every
to
time we
define
need
a
to
color,
define a
we
color,
need to
we
load
need to
USD
load
shade
USD
dot
shade
material
dot
schema
material
API.
schema API.
Yep.
So
Got
every
that.
time we
Every
use
time we
this, it's
use this,
gonna do
it's
like an
gonna do
API
like an
call
API
to
call
USD,
to
right?
USD, right?
Yeah, we need to use that material API
Mm-hmm.
Mm-hmm.
because I think that's what it's saying basically, that okay, hey, we need to wrap our object into a colored material, not a color, but a colored material.
Material. Okay, let's
Material. Okay,
put this
let's
in
put
Gemini
this in
now
Gemini
and
now and
understand.
understand.
I'll say
I'll
we
say we
understand
understand
that
that
this
this
is
is
done to
done to
define the
define the
color
color
green,
green,
but
but
why
why
is it
is it
so
so
complicated?
complicated?
Pixar
Pixar
animation.
animation.
It feels
It
complicated
feels
because
complicated
OpenUSD
because
isn't
OpenUSD
just a
isn't
3D file
just a
format,
3D
it's
file format,
shading
it's
network.
shading network.
In similar
In
art
similar
terms,
art
green is
terms,
just a
green is
single
just a
setting.
single
In
setting.
professional
In
VFX
professional
robotics,
VFX
green could be
robotics,
a
green
complex
could be a
mix of
complex mix of
textures
textures
or light
or light
behaviors.
behaviors.
Here is why the
Here
each
is why the
line
each line
behind each line
behind
broken
each
down
line
into
broken
simple
down into
concepts.
simple
Green equals
concepts.
to
Green
USD
equals to
dot shade
USD dot
material
shade
defined
material
stage
defined
green mat.
stage green mat.
Why you can't
Why
have
you
a
can't
color
have a
floating in
color
space?
floating
You
in
need
space? You
a
need
material
a
print to
material
act
print
as
to
the
act
envelope
as
that
the
you
envelope that
eventually
you
nail
eventually nail
bind to your 3D
bind to your
object.
3D object.
What is this
What is this
material?
material?
Ah,
Ah,
bruh.
bruh.
Okay.
Okay.
Uh,
Uh,
the engine,
the
the brains,
engine, the
green
brains, green
PS.
PS.
USD shade dot
USD
shader
shade
dot
dot shader
define
dot define
stage.
stage.
USD shade dot
USD
shader dot
shade dot
define
shader dot
stage.
define
Green dot
stage.
get
Green dot
path.
get path.
Yes, it got a
Yes,
path
it
over
got a
here,
path
and then
over here,
append
and then
path
append
preview
path
surface.
preview surface.
Green dot
Green
PS,
dot
green
PS,
PS
green
dot
PS
create ID
dot create
attribute.
ID attribute.
USD preview
USD preview
surface. Why
surface. Why
a material
a
is just
material
a
is just a
container? It
container.
doesn't
It
know how
doesn't
to
know
look
how to
like
look like
anything.
anything.
The shader is
The
the
shader
actual
is the
math
actual
engine that
math engine
calculates
that
how
calculates
light
how
hits
light
a
hits a
surface.
surface.
The shader is
The
the
shader
actual
is the
math
actual
engine
math
that
engine
calculates
that
how light
calculates how
hits
light
the
hits the
shader.
shader.
Oh, I
Oh,
think I
I
understood
think I
why we are
understood why
using
we are
this
using this
green
Mm-hmm.
PS.
green PS.
It's because
It's because
it needs to
it
define
needs to define
how the
how
material
the
will
material
react
will
when the light
react when
hits
the
the
light hits the
surface.
surface.
Look
Ooh.
at
Look
this.
at
Calculate
this.
how light.
Calculate
So the
how light.
actual
So the
math
actual
engine
math engine
for that.
for that.
The shader is
The
the
shader
actual
is the
math
actual
engine
math
that
engine
calculates how
that
the light
calculates how
hits the
light
surface
hits
by
the
setting the
surface by
ID
setting the ID
to
to
USD preview
USD
surface. You
preview
are telling
surface. You are telling
OpenUSD use
OpenUSD
universal
use
lighting
universal lighting
model that
model
every
that
3D tool
every 3D tool
understands. So
understands.
it's
So
basically
it's
defining
basically
how
defining
that
how
green
that
texture
green
would
texture
react to
would
different
react to
light
different light
settings
settings
over there.
over there.
Okay.
Okay.
And what
And what
USD shade
USD
dot
shade
shader
dot
dot
shader
define.
dot define.
Okay.
Okay.
Green PS
Green
create
PS
input
create
diffuse
input
color
diffuse
set
color set
GF vec
GF
3D
vec 3D
3F.
3F.
Shaders have many
Shaders have
knobs
many knobs
inputs
inputs
like roughness,
like
metallic
roughness, metallic
opacity. Here you
opacity. Here
specifically
you
grab
specifically grab
diffuse color
diffuse
knob
color
and
knob
turning it
and
to
turning
green.
it to green.
Okay, so
Okay,
shaders
so
have
shaders
many
have many
knobs like
knobs
roughness,
like
metallic,
roughness,
and
metallic, and
opacity.
opacity.
Create input.
Create input.
So, okay.
So
Oh, I
okay. Oh,
understood.
I understood.
Here it is
Here
defining
it is
green
defining
PS
green PS
to USD
to
shade dot
USD shade
shader
dot shader
dot define.
dot
So it's
define. So
gonna
it's gonna
use the
use the
USD shade dot
USD shade
shader
dot shader
schema API,
schema API,
and then
and
in
then
that schema
in that schema
API, it's
API,
gonna
it's
use
gonna
diffuse
use
color
diffuse color
over here
over
to
here
tell
to
that
tell that
okay, we are gonna
okay, we are
choose the
gonna
green
choose the
color
green color
for this
for this
Mm.
texture.
texture.
You're telling
You're telling
OpenUSD
OpenUSD
use a
use the
universal
universal
lighting model
lighting
that
model
every
that
3D tool
every 3D
understands.
tool
So we are
understands. So
using
we are using
shade
shade
shaders have many
shaders
knobs
have many
inputs like
knobs
roughness,
inputs like
metallic,
roughness,
opacity.
metallic,
Here you are
opacity. Here
specifically
you are
grabbing
specifically
the diffuse
grabbing the
color knob
diffuse
and
color
turning
knob
it to
and turning
green.
it to green.
010 in
010
RGB.
in
See, I was
RGB.
telling
See, I
you.
was telling you.
Yeah, yeah, rude. I
And
accepted
then
it.
And then
grade
grade
green dot
green
create
dot
surface
create
output
surface output
dot connect to
dot
source
connect to
green
source
PS
green PS
connectable API
connectable API
surface.
surface.
This is why
This is why
this is usually the
this is
most
usually the
confusing
most
part. Just
confusing
because
part.
you
Just
created a
because you
shader
created a
inside a
shader inside a
material
material
doesn't mean they are
doesn't
talking
mean
to
they are
each
talking
other.
to each other.
Hmm. Oh. Oh, I see, I see, I see. So if you bind it, connect to source, wait.
Connect to
Connect
source
to
green
source
PS
green PS
connectable API
connectable API
surface.
surface.
What was
What was
preview
preview
surface?
surface?
Create surface
Create surface
output.
output.
Connect to
Connect to
source green
source
PS
green
connectable
PS
API.
connectable API.
Create surface output.
Got it.
Got it.
This usually
This
via
usually
the line
the
plugs the
line
shader
plugs the
into
shader
materials
into
output
materials
port.
output port.
So okay,
So
so create
okay, so
simple.
create simple.
So this is a
So this
typeless
is a
container
typeless container
over here.
over here.
We are
We
creating
are
a
creating
material
a
inside
material
that
inside
typeless
that
container
typeless
over here
container over
called
here
green.
called green.
And then
And then
this line
this
basically
line
plugs the
basically plugs the
shader
shader
into that
into
material's
that
output
material's
port.
output port.
So whenever
So
that
whenever that
material will get
material will
output,
get
like
output, like
whenever that
whenever that
prim is
prim
going to
is
get
going to get
you know
you know
previewed,
previewed,
it's gonna
it's
turn
gonna
green
turn green
because of this
because
line,
of this
because this
line,
is the
because
one
this
that
is the
is
one that is
connecting this
connecting
part.
this part.
Like
Like
this is the line that
this
is
is the line that is
responsible for
responsible for
showing that
showing that
material as
material
green.
as green.
Think of it as a
Think of it as a
material, as a
material,
TV
as
and
a
shader
TV
with a
and
Blu-ray
shader with a
player.
Blu-ray player.
You have to run
You
an
have to run
HDMI
an
cable.
HDMI
This
cable.
connection
This
between
connection
them,
between
or
them,
the screen
or the
stays
screen
black.
stays
Correct.
black.
Got
Correct.
it.
Got it.
Lamp
Lamp
base, light
base,
bulb,
light
input
bulb,
color
input color
of the
of the
glass
glass
on the bulb,
on the
connection
bulb,
screwing the
connection
bulb into
screwing
the
the bulb
socket.
into the socket.
Okay, I got it.
Okay, I got it.
Oh,
Oh,
bro,
bro,
I think I'm
I think I'm
understanding like
understanding like
how
Mm,
how
OpenUSD works
OpenUSD
now.
works now.
I see.
I see.
I see.
Yes, I think I
Yes, I
am
think I am
understanding it.
understanding it.
Similarly for red,
Similarly for
they
red,
did the
they
same
did
thing
the
over
same thing
here.
over
They
here.
just put
They
like
just put
defining
like
red as
defining red
a
as a
material, and
material,
then the
and then the
shader is
shader is
basically connecting
basically
it
connecting it
to the
to
material
the
like
material
output.
like output.
Over here, create
Over here,
surface
create
output,
surface output,
connect to
connect to
source,
source,
red PS
red
connectable
PS
API
connectable API
surface.
surface.
And then
And
over here,
then
they are
over
just
here, they are
connecting
just
all of
connecting all
those
of those
materials
materials
to particular
to particular
cubes and
cubes
then
and
rendering
then
it.
rendering it.
Easy,
Easy,
easy work.
Yes.
easy work.
Easy peasy. Looks like it. But we will figure out once we start working with it.
So this is what the
So this is what
USDF
the
file looks
USDF file
like.
looks like.
Def cube
Def
one
cube one
API material
API
binding
material
API.
binding API.
Okay, so have
Okay, so have they?
they? Okay,
Okay,
over here.
over here.
Got it.
Got
Got
it.
it. Got it.
Got
Got
it. Got
it.
it. Got
I
it.
think I
I think I
understand how this
understand how
works
this
now.
works now.
Prepend API
Prepend API
schemas
schemas
are also
are
defined
also defined
when
when
this. So this is
this.
the
So
type
this is the
X
type
form
X
type
form
world.
type world.
And then
And
where is
then
this
where is
looks?
this
Yes,
looks?
this is
Yes, this is
typeless
typeless
because
because
they need to
they need to
be
be
flexible.
flexible.
That's why this is
That's why this is
typeless. And
typeless. And
then
then
there is
there is
material.
material.
Yes, this
Yes,
is
this is
material is
material
type
is type
container
container
USD
USD
material
material
binding API.
binding
Yes,
API. Yes,
sir. I think I
sir. I think
understand
I
this,
understand this,
bro,
bro,
completely.
completely.
Mm,
Oh my
okay.
god,
Oh
this
my
is the
god, this
first
is the
time
first
I
time
understood
I
code
understood code
by just looking
by
at
just
it.
looking at it.
Like I'm
Oh my
finally
I'm
god.
getting it.
finally getting it.
Are you AI? Is it Cloud Code Mythos?
Mythos in
My
my
thoughts in my
ass.
ass.
Mythos, is it you? Mythos, yeah, Mythos, whatever the fuck is.
Got it. Key
Got it. Key
takeaways. Bro, I think we
takeaways.
should
Bro,
do
I think we
time
should
code
do
and time
time code and
samples
time
also
samples
today.
also
We
today.
did this
No,
really
Did
no,
this
no,
fast.
really
no,
fast.
not today, not today. I'm too
Bro,
tired,
it's
dude.
just
Bro, it's just
11:58.
I don't
11:58.
know, dude. Like I was not able to sleep yesterday, dude. I'm not able to focus that much. That's why I told you that we
Bro,
will stream
few
early.
Few
moments
moments
of
No, bro. It's
peace.
all about it's all. Dude, I have a lot of work. I'm telling you, this week, that only this week, I have some work that I need to just deploy some things. Once they
Mm-hmm.
are completed, I would be able to focus much more.
I
I
Once they are deployed,
see.
then definitely.
I
I
see. But we are gonna
see. But
do
we are gonna
quiz
do quiz
regardless.
regardless.
Yeah, we are gonna do the quiz.
Okay, key
Okay,
takeaways.
key takeaways.
Relationships enable
Relationships
robust
enable
encoding of
robust encoding
dependency
or
and
dependency
association
and
between scene
association
elements,
between
such
scene
as
elements, such as
binding geometry to
binding geometry
materials,
to materials,
grouping prims into
grouping prims
collections,
into collections,
establishing connections
establishing
into
connections
shading
into
in shading
shading in
networks,
shading
correct?
networks, correct?
Associating scene
Associating
elements
scene
with
elements with
non-hierarchical
non-hierarchical
links, example
links,
material
example
binding.
material binding.
Using
Using
relationships instead
relationships
of hard
instead of
path
hard
enhances
path enhances
non-destructive editing
non-destructive editing
workflows,
workflows,
referencing and
referencing
asset
and asset
reuse across
reuse
tools,
across tools,
collaborative workflows
collaborative
across
workflows
teams.
across teams.
Relationships are a
Relationships
way
are
to
a
link
way to
scene
link
elements
scene
while
elements
enabling
while enabling
non-destructive editing and
non-destructive editing
cross-tool
and cross-tool
collaboration.
collaboration.
They enhance the
They enhance the
flexibility and
flexibility and
scalability of
scalability of
OpenUSD-based
OpenUSD-based
pipelines.
pipelines.
Okay,
Okay,
easy.
easy.
Relationships was pretty
Relationships was
easy.
pretty easy.
Hmm.
I'm gonna
I'm
put
gonna put
this
this
in this
in this
to
to
generate a
generate a
quiz
quiz
for
for
relationships now.
relationships now.
I've asked it
I've
to
asked it to
fetch
fetch
more code
more code
examples from
examples from
online
online
to test our
to test our
understanding.
understanding.
Hmm.
Let's see what
Let's
this
see
shit
what this shit
wants. Bro, look at
wants.
this. I
Bro, look
told
at
you
this. I
this was
told you
not
this
gonna
was not
happen
gonna happen
automatically.
See, at
automatically.
least, one step at a time. Small steps.
Bro, people
Bro,
are
people are
watching, bro.
watching, bro.
Yeah, damn.
44 views.
44 views.
Holy shit. What the fuck? Uh,
Or should I
Or
put
should
it in
I
a
put it in a
different one?
different one?
From the web
From the
to
web to
test.
test.
I'll be right back.
I'll be right back.
mhm.
Hmm.
Hmm.
All right,
All
let's
right,
do it.
let's do it.
26 questions.
26 questions.
In OpenUSD,
In
which property
OpenUSD,
type
which
is
property
specifically
type is
designed to
specifically
store path
designed to store
values to the
path values
pointers
to the
as seen?
pointers as seen?
Yeah.
Yeah.
What happened to the
What happened
relationship's
to the
target?
relationship's
Okay.
target? Okay.
Path if
Path
the target
if the target
prim is moved
prim
or
is
renamed
moved or
during
renamed during
composition
composition
reference.
reference.
Come on, bro,
Come
tell
on,
me.
bro,
I
tell
know
me.
this one.
I know this one.
D.
Yes, sir.
Yes, sir.
If you need to
If you
connect to
need to
already
connect to
existing
already
attributes
existing
on different
attributes on
prims.
different prims.
If you need to connect to
If you need
already
to connect to
existing
already
attributes on
existing
different
attributes on different
prims,
prims,
which mechanism should
which
you use
mechanism
to
should you use to
according to the
according
OpenUSD
to the OpenUSD
documentation?
documentation?
A relationship property.
Right.
Right.
If you need to connect
If
to
you need to
already
connect to already
existing.
existing.
Yeah, relationship
Yeah,
property.
relationship property.
What?
What?
Attribute connection.
Attribute connection.
Yeah. Okay.
Bro, what the
So
fuck?
the
What the fuck?
documentation explicitly states that the attribute connection should be used to link to pre-existing attributes. Okay.
But
But
isn't that
isn't that
the
the
relationship?
relationship?
No, dude. The question talks about attribute, not relationships. If you want to connect two prems, then we will use a relationship, right? But I think if you want to connect two attributes, then we would use attribute connections. Because in
Oh,
our
this
example,
is
Oh, this
relationships
is
are used to
relationships are
declare a
used to declare
property
a
whose
property
sole
whose
purpose
sole
is
purpose
linkage,
is
not to
linkage,
connect
not to
existing
connect existing
attributes.
attributes.
yeah.
Ooh,
Ooh,
okay. I didn't know
okay. I didn't know
this.
this.
But why do
But
I feel
why
like
do I
this
feel like
might be
this might
a
be a
wrong?
wrong?
I asked
Can you
Google.
check
Can you
this
check
question
this
and
question and
answer?
answer?
Ashwan, he be just like
He be
me.
just like me.
Okay,
Okay,
got it.
got it.
Next question.
Next question.
Which Python method
Which
is used
Python
to
method is
define
used to
a new
define a
relationship
new
on
relationship
USD
on
prim
USD prim
object?
object?
D.
Create relationship.
Create relationship.
Yes.
Are you
Are
sure?
you sure?
Yes.
Bro, I think
Bro, I
it's
think it's
B.
B.
Go ahead. Go ahead. Do B.
There is nothing
There
like
is
create
nothing like
relationship,
create
bro.
relationship,
This is
bro.
only
This
the
is
See,
one.
there
only
is.
the one.
Go down, dumbass.
Yeah.
Over here.
Yeah.
Check.
Oh yeah,
Oh
group
yeah,
dot create
group dot
relationship.
create relationship.
Okay, you're
Okay,
right.
you're right.
Dot.
Dot.
Bro, wait.
Bro, wait.
Okay, yeah,
Okay, yeah,
you're right.
you're right.
The create
The
relationship
create
method is a
relationship
standard way
method
to
is a
author a
standard way to
relationship
author a
property on a
relationship
prim.
property on a prim.
Which schema
Which
utilizes
schema
a
utilizes a
built-in relationship
built-in
called
relationship
proxy
called
prim to
proxy prim
associate
to
a
associate
high-cost
a high
prim
cost
and
prim
A.
lightweight
and lightweight
imageable
imageable
USD?
USD?
Correct.
Yes, correct.
Imageable. USD
Imageable.
geom dot
USD
imageable
geom dot
schema
imageable
API.
schema API.
In the context of
In the
material
context of
binding, this
material
relationship
binding,
was
which
authored to
relationship is
link
authored to
geometry to
link
USD
geometry to
shared
USD
material.
shared material.
USD
Material
USD
binding.
shared.
shared.
No, material binding is used for
Material binding
Material binding
API,
API,
but
but
geometry. But I think yeah, it's gonna be based on my assumption. It's gonna be material binding, but I might be wrong.
which
which
relationship is
relationship is
authored
authored
to link
to link
geometry
geometry
to a
So
USD
to a
geometry.
USD
material.
So
USD.
material.
so
USD.
geometry is X form, and so it's gonna be I think D. Yeah, it's gonna be D.
Wait, which
Wait, which
relationship is
relationship is
authored
authored
to link
to link
geometry to a
geometry to a
USD shade dot
USD shade
material?
dot material?
I think
I
it's
think
it might
it's
this
it
might be
might this
wrong,
might
bro.
be
This is
wrong,
a
bro.
trick
This is a
question.
trick question.
Okay.
Oh, that's right.
Oh, that's
Okay.
right. Okay.
The material
The
binding is
material binding
specifically
is
encoded
specifically
using a
encoded using
relationship
a
named
relationship named
material binding.
material
Ah,
binding.
okay.
Okay.
Why are
Why are
relationships considered
relationships
beneficial
considered
for
beneficial for
collaborative workflows
collaborative
across
workflows
different teams?
across
They allow
different teams? They allow
non-destructive editing and
non-destructive
robust
editing and robust
referencing of
referencing
assets.
of
They
assets. They
automatically log the
automatically
target
log
from
the
preventing
target
other
from
teams or
preventing other
editing.
teams or editing.
It's A.
It's A.
Hmm.
Non-destructive editing
Non-destructive
and robust
editing and
referencing
robust
of
referencing of
assets.
assets.
When querying
When
a
querying a
relationship,
relationship,
First target using the Python API. Which method should we use to inspect the stored paths? Get targets.
yes.
yes.
Returns a list
It
of
is a
paths
list
that
of paths
relationship
that
is currently
relationship is
pointing
currently pointing
to. That's right.
to.
That's
That's
right.
right. That's right.
Which of the
Which of
following
the
is a
following
valid
is a
target for
valid target
relationship
for relationship
property? Which of the
property?
following is a
Which of the
valid
following is a
target for
valid target
relationship
for
property?
relationship property?
Only other
Only
prim.
other prim.
Only metadata
Only
keys.
metadata keys.
Only prim's
Only
attributes
prim's
or
attributes
other
or other
relationship.
relationship.
Uh,
D.
D.
I think it's
I
D.
think it's D.
but no wait.
Brother,
Oh.
Brother,
I read it.
I read it.
I read it over
Oh.
I read
there
it over there.
I thought
in
earlier
the
we had
In
an
beginning.
the
issue with
beginning.
attributes, right? Relationships were not able to connect to attributes.
Everything, bro. You
Everything,
can
bro.
get
You can get
everything in that
everything in that
because it's a
because
typeless
it's a
container,
typeless
right?
container, right?
So I think I
So
read
I think I
somewhere
read
that
somewhere that
like everything
like
was inside
everything was
it.
inside it.
Every prim's
Prim's
attributes,
attributes,
relationships, you can get
relationships, you can
everything.
get everything.
Okay.
Okay.
A
A
relationship can target
relationship can
variety of
target
scene
variety
graph.
of
Yeah,
scene graph.
variety
Yeah,
of scene
variety
graph
of scene graph
objects,
objects,
including prim's
including
attributes
prim's
and even other
attributes and even other
relationships.
relationships.
How do
How
relationships
do
differ from
relationships differ
attributes
from
regarding their
attributes
data
regarding
type
their
in
data type
OpenUSD
in
of
OpenUSD of
link type?
link type?
Yes.
Relationships in
Relationships in
OpenUSD can
OpenUSD
only
can
point to
False.
only
single
point to
target
single
path.
target path.
Only,
Only,
bro. Wait,
bro,
a
wait.
relationship
A
in
relationship in
OpenUSD can,
OpenUSD can.
bro.
Bro,
Wait.
wait.
Dude, just do it. Just do it.
Okay,
Okay.
Fuck you.
their
Dude, I,
documentation
in the
documentation.
starting we did discuss that a relationship can have one to many relationship.
Yeah,
Yeah, yeah.
So it makes sense that it should not be like a relationship in OpenUSD can point to multiple target paths rather than a single path.
got it,
Got it.
got
Got
it.
it. Got it. Got it.
Which Python
Which
API
Python
class is
API class
mentioned
is
as being
mentioned as being
responsible for
responsible
authoring
for
and reading
authoring
the
and
material
reading the
binding
material binding
relationship?
relationship?
Material binding
Material
API.
binding API.
Mm, yes. Dude, this quiz has like elimination rounds.
Yeah.
Yeah.
What is the
What
primary
is the
role of
primary
part
role of part
translation
translation
in the context
in
of
the context of
OpenUSD
OpenUSD
relationships? Which
relationships? Which
part of part
part
translation?
of part translation?
Path translation in the context of OpenUSD relationship. What is the primary role of path relation in the context of OpenUSD relationship?
Yes, D.
Yes, D.
To map author target's path to the corresponding object in
Yeah,
Python.
bro.
Yeah, bro.
Bro, this is they
Bro,
are
this
just
is they are just
complicating that we
complicating
just read
that we
over
just read
here.
over
Like,
here. Like,
if
if
initially we read
initially
right,
we read right,
if
if
the
the
thing like if
thing, like
their
if their
like
like
that
that
changes,
changes,
path
path
changes,
changes,
they
they
automatically do path
automatically do path
translation.
translation.
So
So
this is what,
this is
yeah,
what,
path
yeah,
translation
part
ensures that the
translation
path
ensures that
stored
the
in the
path stored
relationship
in the
authored
relationship
resolve
authored
even
resolve
after
even
composition
after
asks,
composition asks,
like reference
like
are
reference
applied.
are applied.
Bro, you know
Bro,
what
you know
I'm
what I'm
feeling?
feeling?
I
We'll
think
see.
as
Don't.
we go down, this is gonna
This
become
is gonna
easier
become
and easier
easier and
because we
easier because we
already are gonna
already are
cover a
gonna
lot of
cover a lot of
stuff.
stuff.
Yeah, I know because we are doing like research by Gemini as well, so we
Yeah.
already know what are the things that we're trying to focus on, right?
Yeah.
Yeah.
According to the
According to the
source, what is the
source, what
one
is the one
non-hierarchical use
non-hierarchical
case for
use case for
relationships?
relationships?
Non-hierarchical
Non-hierarchical
use case
use
for
case for
non-hierarchical defining
non-hierarchical
parent-child
defining
bro.
parent-child role.
According to the source,
According
what
to
is
the
the
source,
one
what is the one
non-hierarchical use
non-hierarchical
case for
use case for
relationship?
relationship?
Dude,
I
this
think
is some
I
C.
kind
think
of vague.
C.
Dude, this is some kind of vague question.
C, bro.
C, bro.
Why do you think it's C?
Because you
Because
remember
you
we were
remember we were
doing
doing
the thing over
the thing
here
over
where we
here
were
But
where
that's
we
for
defining a
were
shader.
defining a
material.
That's for
material.
shader. That's for
Yeah,
shader.
but
That's
Yeah,
not
but
for.
we are gonna use
but
But
the
we are gonna
according to
use
the
the
relationship.
source,
relationship.
dude. First of all, that is a very vague question over there. Like according to the source, what do you mean by that? What is the one non-hierarchical use case for relationship? It could be D as well, defining parent-child links because we do define parent-child links as well. But yeah, definitely it can be C as well. What
According to
do
the
you
According to
think?
source,
the
what is
source,
one
what
of
is
one
one
non-hierarchical?
non-hierarchical?
So it can also be B, right? Like it. That's because in that scenario you are not.
Oh, it will be
Oh, it
B. I
will be
think it will
B.
be
I think it
B.
will
Yeah,
be B.
I think it will
because
be
I think
B.
it will be B.
yeah, you are just binding it to any of the cube or the sphere that we saw
And
over
this is
there.
material binding is
Material
gonna be
binding is gonna be
non-hierarchical. Let me see
non-hierarchical.
what
Let
the
me see
hints
what the
is.
hints is.
Yeah, I think it's
Yeah,
gonna
I
be
think it's
B.
gonna be B.
Yes,
Yes,
sir.
sir.
Ooh, nice.
If the
So we need
provided
to
If the
bind
material
it
provided
to
binding
material
two.
binding
example, if
example,
green
if
mat
green
is
mat
bound
is bound
to two
to two
cubes, how many
cubes, how many
targets
targets
does the material
does the
binding
material binding
relationship store?
relationship store?
For that
For
material,
that
how many
material, how many
targets? I
targets?
think two,
I
right?
think two, right?
Yeah, it should be two
Or is this a
Or is
trick
because
this a
question?
trick question?
both of the cube will have the target should be one. No, cube one, cube two. When you're cutting, yeah, it's gonna be two. It's gonna be two. It's gonna be two.
Let me see what the
Let me see
hint
what the
says.
hints.
I think this is a
I think
trick
this is
one.
a trick one.
Yeah, two, right?
Yeah, two, right?
Yep.
Yep.
Allowing a
Because it
single
Allowing
says
a
link to
single
multiple
two.
link to
target
two.
paths, and when we define two cubes, we are defining them differently, right? We are not
Uh,
defining them in a single line. We need to append two paths. That this is the cube one and this is the cube two that we are gonna append in our stage.
yep.
Yep.
Next, why is using a relationship preferred over a hard-coded path string in an attribute?
Why is using a
Why is using a
relationship
relationship
prefer over
preferred
a
over a
hard-coded
hard-coded
path?
path?
Use
Use
memory.
memory.
Yes, C.
Yes,
I think
C.
it's gonna be
I think
C.
it's gonna be C.
Part
Mm,
Part
translation.
translation.
yes.
Beautiful.
Beautiful.
Are aware of the
Are
same
aware of
graphs
the
and
same graphs
participated
and
in part
participated in part
translation, whereas
translation, whereas
yes.
yes.
Which of the
Which
following
of
is
the
not
following is
listed
not
as key
listed as
takeaway
key
for
takeaway
using
for using
relationship
relationship
in
in
okay, default the
okay, for the
prim
prim?
I think A.
I think A.
No. Yeah. Oh wait. Dude,
Cheating.
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 I
Defining
think
the
it's A,
I think
bro.
it's
difference.
A, bro.
A.
Yeah.
Okay.
Yeah.
Not a
Not a
relationship property.
relationship
Default
property.
prim is
Default prim is
metadata
metadata
composition setting.
composition setting.
If you wanted to
If you
see the
wanted to see
Python
the
code for
Python code
authoring
for
a prim
authoring a
collection
prim
with
collection with
relationships,
relationships, which local tool setup
is
is
recommended by the
recommended
tip
by the tip
in the
in the
source. What?
source.
If you
What?
wanted to
If you
see
wanted to
Python
see
code for
Python code
Jupyter
authoring,
for
Notebook
authoring,
D. Hit D.
okay.
But this is some
okay.
bullshit. Next.
When declaring
When
relationships
declaring
at creation
relationships
time,
at
what is the
creation time, what
primary
is the
intended
primary
use of that
intended use
property
of that
defined as a
property
base
defined
state
as a base state store
store linkage
linkage
information D.
information D.
Yes.
Linkage.
Linkage.
Python
Python
OpenUSD.
OpenUSD.
API, what is the
API, what
method?
is the
Get
method?
targets,
Get
return
targets,
boolean,
return boolean,
list
list
single string
single string
values,
values,
I think it
list
should
of
be.
list
USD
of USD
It should
prim.
be B. SGF paths. But wait, it's a relationship, and then we define the targets. Yeah, it should be B.
Yeah,
yeah,
objects, because all
objects,
the
because all the
targets like
targets
are
like are
objects which are in a
objects which are in a
relationship.
relationship.
But D is also an option because it also talks about objects a list. So I know for sure
I
it's
think it's
gonna
gonna
I
it's
be
think
gonna
D.
it's gonna
return
be D.
it's
I
gonna
think it's gonna
I
be
return
think
D.
it's gonna be D.
okay. I will go with D. You go with D.
Oh,
Yay! SGF path. I think it's so. The thing was, we do have an example of SGF path over there, so that's why I went with it.
which one?
Which one?
So go up. Yeah, down. I think it's gonna be over here. We do SGF path. We do. It does mention somewhere about SGF path. Go down. I think it should. Wait, let me check on that one. Oh, search command F. Do a command F. You will find. It does mention about SGF path somewhere.
Okay.
Okay.
Over here. Wait, I don't know. Wait, SDF. Only three. Oh. What was the question?
USD
Yeah,
everywhere.
okay. Get targets. And why was D not the correct option? While they point to the prims, it returns SGF paths. It
Oh, the
returns
path
SGF
which can
paths.
be
Which
used
can
to
be
get
used to
prims.
get
Yeah.
So
frames.
list of
So list of
SDF path
SDF path
objects.
objects.
I
I
see. Got it.
see. Got it.
This returns the
This returns the
path list,
path list,
not, and this
not,
returns
and
the
this
objects
returns the
itself.
objects itself.
Bro, let me see
Bro, let
what the
me see
fuck
what the
this is
fuck this
doing.
is doing.
Okay, dude. Quiz.
1 second, bro.
1 second, bro.
Bro, I think this
Bro, I
is
think this
gonna
is gonna
take a lot of
take
load
a lot
on
of load
my
on my
Mac.
Mac.
You have M3, right?
Arey,
Arey,
I have
I
M3,
have
bro. I'm
M3,
not
bro. I'm not
Dude, M3 is
running
more than good
on.
enough, dude. People running M1.
But I'm also
but I'm
running
also
a
running a
shit ton of
shit ton of
Quiz.
shit ton of
shit ton of
software as well,
software
bro.
as
That's
well,
fine.
bro.
If it crashes, then we will do a rep. Under which subheading in the table of content would you find information about relationships? Oh.
Abeh.
Abeh.
This statement
This
best
statement
describes the
best describes
relationship
the
between
relationship
proxy
between
prim and high
proxy
cost
prim and high cost
geometry.
geometry.
Proxy prim is
Proxy
reference
prim
to
is
external
reference to
USD
external USD
representation, but the
representation, but
high
I
cost
think it
high
should be
prim
cost
B.
prim
to yeah.
to yeah.
What is the
What is
attribute?
the
What is the
attribute? What
primary
is the primary
conceptual difference
conceptual
between
difference between
relationship
Prime
and
relationship
attribute?
and
and
attribute?
Wait, what? What
Wait,
is the primary
what is the
conceptual
primary
difference between
conceptual difference between
relationship and
relationship
attribute
and attribute
connection?
connection?
Yes, A,
Yes,
but
A, but
attribute connection are
attribute
fast to
connection are fast to
know.
know.
Hmm.
Hmm.
I think it should
I
be
I
A
think it
think
or
should be
D.
A or D.
it
Only
should be
point to
Only point to
prims.
prims.
it should be D.
Yeah.
Yeah.
Because it talks about the creating linkage, but the A doesn't talk about it. GRE. You went out. Next.
How
How
relationships enhance the
relationships enhance
flexibility
the
and
flexibility and
scalability of
scalability of
OpenUSD based
OpenUSD based
pipelines.
pipelines.
By enabling non-destructive editing, cross-tool collaboration through robust linkage. How do relationship enhance the flexibility? I think it should be A.
How do
How do
relationships enhance
relationships
the
enhance the
flexibility
flexibility
and
and
scalability
scalability
of
of
OpenUSD based?
OpenUSD based?
Bro, yes,
Bro,
that
yes,
shit
that
is
shit is
running wild
running
on my
wild on my
laptop.
laptop.
It's building something. Steady outage buffer. Open your activity monitor. We can see.
Bro, my fans
Bro,
are
my
on.
fans are on.
So that's fine, dude. If fans are on, open your fucking activity monitor. Look at the memory pressure. What
Bitch
do we have
ass.
over here?
Bitches.
Look, memory pressure is good. Look at the CPU. Look at the CPU. Look at the CPU. CPU is also doing, dude. It's only at 80%.
Only.
Only.
Only at
Oh,
80%.
bitch
Mac can
ass.
handle it.
Bitches.
Mac can handle it easily. And let's complete the quiz quickly. Let's go. Let's go. Let's go.
How do relationships
Our
enhance the
relationships enhance the
flexibility and
flexibility and
scalability of
scalability of
OpenUSD based
OpenUSD based
pipelines?
pipelines.
A.
Yeah.
Yeah.
Next, would you use to retrieve an existing relationship from? I think dot get it should be dot get, but I don't know. I'm just guessing it.
Which of these
Which of
commands would
these
you
commands would
use
you
to
use
retrieve an
to
existing
retrieve an existing
relationship?
relationship?
Oh, find
Oh, find a.
I think
I
D.
think D.
D. Yeah, that's what I said. D.
Yes.
Yes.
Yeah. Next, I think the last one.
Yep.
Yep.
Okay. All right. Done. I think, and we have
24.
For
two wrong. That's fine.
Another
All right,
day.
another
guys.
day.
Successful
Another day.
stream.
Successful stream.
Successfully
Successfully
stood
stood
consistent.
consistent.
We could have done
We could
this
have
as
done
well,
this
but
as
your
well,
bitch
but your
ass
bitch
Dude,
ass
tuned
yeah,
doesn't.
tuned
bro,
in
it's
doesn't.
fine. It's fine. Just let us take this week only slow, and from the next week we are gonna ramp it up much higher.
Ramp it
We're
up
gonna
Ramp
much
it up
higher.
much
ramp it
higher.
up much higher. I'm gonna force you to work all night, all day, motherfucker. Don't worry, don't worry. I'm gonna fucking force you
Now,
to.
what do you want
Now,
to
what
do
do you
about
want to
this,
do
bro?
about this,
Like,
bro?
Keep
let's.
Like,
doing it,
let's.
dude. But let's see if your MacBook burns out, then claim the warranty.
Fuck you, bro.
Fuck
I'm
you,
not
bro.
gonna
I'm
take
not
that
gonna take
risk.
that
Fuck
risk.
you.
No,
Fuck
it
you.
won't do anything, motherfucker. It won't do anything. Macs have fail safe. It won't break. It's just building it. That's why it's taking it has a lot of load on your CPU. But M1 chips are meant for rendering, video editing, frames, and all those shit.
How do I see it
How
in
do I
Windows.
see it
Ghosty,
in
bro?
Ghosty, bro?
What? What do you wanna see?
I wanna see
I wanna see
where
where
it is
where it
rendering
is
the
rendering the
shit.
It's
shit.
not rendering. It's building. Like if you want to check, do down arrow.
What down arrow?
What down arrow?
Down arrow. Press down arrow. Click down arrow.
Yeah.
Yeah.
Yeah. Enter. This is a task that it is working on right now. This is the shell task that is running and that is burning your compute. It open USD build progress over here. Output error. Holy shit. You have to kill it. Press X. You just killed it. Check the log. All right.
What alright,
What
bro? Tell
alright,
me what
bro?
to
Tell
do
me
over
what to
here.
do over here.
Ask Cloud Code, bro. What to do? AI knows. AI will guide us. The one and only.
Hmm.
Mm-hmm.
What the
What
fuck
the
is it trying
fuck
to
is it
do?
trying to do?
All right, guys.
All right,
All
I'll
right,
stop the
I'll
stream
stop
now.
the stream now.
Mhm.
I think we
I
streamed
think we
for
streamed
another two
for
hours,
another
right?
2 hours, right?
1 hour
One
45
hour
minutes.
45
Now
minutes.
41 minutes.
How many
How many
viewers?
viewers?
47.
47.
Not bad.
Not bad.
All right.
All right.
Adios,
Adios,
motherfuckers.
motherfuckers.
Come again
Come again
tomorrow.
tomorrow.
Later.
Oi.
Later.
Yes.
Yes.
Peak concurrent
Peak
views
concurrent
3.
views 3.
सरकार देख के गए होगे